Show that for Z1 and Z2 being complex numbers, the product of Z1, Z2, and then the conjugate of the answer is equal to the conjugate of Z1 multiplied by the conjugate of Z2. In a similar way to the last two examples, we start by letting Z1 be A plus BI, Z2 be X plus YI, where all of those constants A, B, X and Y are real numbers, so they abide the rules of real numbers. Then Z1 dot Z2 conjugate, so the multiplication of Z1 and Z2 is going to be A plus BI times X plus Y, missed the I there, I, and all of that we want the conjugate of it. So expanding inside that bracket, going to get AX plus AYI plus BXI plus BYI squared conjugate, and then grouping together the real and imaginary parts, going to get AX, now I squared is -1, so that's going to become minus BY, and then plus AY plus BX times I. Now the conjugate of that is going to be AX minus BY minus AY plus BX I, negating the imaginary part. Now in this case I could go directly through it, but I actually think it's easier in this case to start with now the right hand side and show that it's equal to the same thing. So now I'm going to take Z1 conjugate and I'm going to multiply it by Z2 conjugate, which is A minus BI times by X minus YI. That's AX minus AYI and then minus BXI and plus BYI squared, which is, grouping together the real parts, is going to be AX. I squared is -1, so that's going to become minus BY. And then this part here, I've got minus AY plus BX times I, when I factorize out this negative part here, and I see that these two things are equal, which means that Z1 multiplied by Z2 conjugate is the same as Z1 conjugate multiplied by Z2 conjugate.